Hello, let's start our next chapter, Continuity and Differentiability. It's a very interesting chapter. Day-to-day life, we see so road is continuous or not. If it is continuous, clear, we travel one place to another place. So introduction of continuity and differentiability. So definition of continuous functions and related problems. Today's class is definition of continuous functions and related problems. A function f of x is said to be continuous if the graph of function has no breaks or jumps. Otherwise, f of x is said to be discontinuous. Let us take an example. This is fx equal to x square, no break at all. Fx equal to x square. What we find? No break at all. This is x-axis, this is y-axis. No break at all. So it is a continuous graph. Similarly, I'll take another graph. F of x is equal to log BCx. Why I'm drawing this graph? It is useful later chapters. This is the graph. So this point is 1, 0. This is x-axis and this is y-axis. Completely continuous. So what is the domain? X is greater than 0. So range is from minus infinity to plus infinity. So domain and range is very important. That's why I keep on mentioning those two. Now I'll take f of x is equal to greatest integer of x. As earlier I told you, 0 to 1, the value is 0. 1 to 2, the value is 1. 2 to 3, the value is 2. This is 1. And this is 2. And this is minus 1. So is it continuous? No, because there is a break at every integer. So it's a continuous function, discontinuous at all integral values. Discontinuous at all integral values. The function f of x said to be continuous. The graph of the function has no breaks or jumps. Otherwise, f of x is said to be discontinuous. You can draw the graph fx equal to x square. This is the fx equal to x square, a D mark. So whenever you draw the graph, you please mention domain and range. Here domain is real numbers and range is positive real numbers. I am including 0. Some authors, they write r plus and 0. So this is domain and range. For this, x is greater than 0 is domain and this is range. In this case, domain is x belongs to real numbers, range only integers belong to z plus. Only integers are considered in this. So clearly it is not continuous, or you can say discontinuous at all integral values. Discontinuous at all integral values. Discontinuous at all integral values. So you got a broad idea what is a continuity of a function. Now we move further. So some disturbance was there. So no problem. Fx is continuous function if the graph of the function has no breaks or jumps, otherwise f of x is continuous. Next one. Note the graph of a continuous function can be drawn without lifting the pen or a pencil from the plane or a paper, for example, x and x square and a constant function. So, this is y equal to x. This is y equal to x, a continuous function. So, what's the domain? X belongs to real numbers. Range is also x belongs to f of x, f of x belongs to real numbers. A straight line, y is equal to x I have to get. So, this angle is 45 degrees. Fx equal to x square already we discussed. This is fx equal to x. Now, f of x is equal to x cube we will discuss. If I draw x cube, so x cube graph is like this. So it is concave down, concave up. This is x-axis, this is y-axis. There is no break at all, continuous function. So what's the domain? X belongs to real numbers. Range is also f of x belongs to real numbers. I hope you got an idea. It's a continuous function. What do you mean by constant function? Constant function means whatever the value you give, this is 0, 0, this is x-axis, this is y-axis, f of x is equal to some 4. So it's a constant function. Whatever value of x you give, the output is always 4. So which type of mapping? Many-one mapping. Many-one mapping. Already we discussed. Why it is many-one mapping? For different values of x, you get only 4. What is this one? 1-1 mapping. Because it cuts at only one point. This is 1-1 mapping. Same is the case for this is also 1-1 mapping. So in a simple language, the graph of a continuous function can be drawn without lifting pen or a pencil from the plane of a paper. Example we have given, y f of x equal to x, f of x equal to x cube, and constant function f of x equal to 4. Why am I always mentioning concave down and concave up? Later classes you will study, you will understand concavity of this one. Next slide. Fx equal to sin x. Let us draw sin x graph. This is x-axis. This is y-axis. We know that range is 1 here, maximum value. Minimum value is -1. This is 0. This is pi by 2. And this is pi. And this is 3 pi by 2. And so on. So sine 0 is 0. Sine pi by 2 is 1. Sine pi is 0. Sine 3 pi by 2 is -1. Similarly, this is minus pi by 2 and this is minus pi. So, sine minus pi by 2 is -1. Sine minus pi is equal to 0. So, f of x is equal to sin x. F of x equal to sin x. What's the domain? X belongs to real numbers. What is f of x? F of x lies between -1 to +1. So this graph keep on continuous. It is goes like this. This is goes like this. So this value is 2 pi. Again this value is 3 pi. and it continues in negative direction also. This is minus 2 pi. What do you observe? After every 2 pi, it is repeating positive, negative, positive, negative. And we know that sine x plus 2 pi equal to sine x. So I'm using a new word here. Sine x is periodic with period 2 pi, periodic with period 2 pi. What is the definition of periodicity? F of x plus t equal to f of x. So what is t? So sine x plus 2 pi equal to sine x. So periodic period 2 pi. So after every 2 pi it repeats. You can also say first quadrant, second quadrant, third quadrant and fourth quadrant. I hope you have understood. So maximum value of sine x is 1, minimum value is minus 1. First quadrant, second quadrant, third quadrant, fourth quadrant. So positive values and negative values. After 2 pi, again it is repeating. Therefore, it is periodic. What is the definition of periodicity? F of x plus t equal to f of x. Sine x plus 2 pi equal to sine x. This 2 pi is the value of t. This is the graph of sine x. So, this also we have studied in for 1 on 2, we take the interval minus pi by 2 to plus pi by 2. Why? All negative values and all positive values. So we already studied f of x equal to sine x when x lies between minus pi by 2 to plus pi by 2. F of x lies between minus 1 to plus 1. I'll draw a line like this. There's no confusion then. F inverse x was sine inverse x. So x lies between minus 1 to plus 1. F inverse x lies between minus pi by 2 to plus pi. Every time I am revising what is taught earlier. So sine x, so inverse is only possible in the domain where positive and negative values are there. So minus pi by 2 plus pi by 2 only we take. So 1 on 2 is possible when it is minus pi by 2 to plus pi by 2. So maximum value of sine x is 1, minimum value is minus 1. So this is the domain, this becomes the range, this is the range, so this becomes a domain. Fx equal to x square already we have drawn. So I repeat once again, f of x equal to sine x is a continuous function and it is a periodic function, and inverse of sine x is sine inverse x. You got the complete details about sine x graph. Next one, fx equal to greatest integer of x. Lot of things we'll study from this. So first of all, definition. Whatever value of x you give, I'll draw a line, make you more convenient. So 0 to 1, 0. It always acquires nearest integer towards left. 1 to 2, this is 3. 2, this is 1, and this is 2. If I talk in negative, so this is minus 1, minus 2, greatest integer minus 2. So this is minus 1, This is minus 2. Now, suppose I take an example, x equal to 2.9. So, greatest integer of x will give you 2. Nearest integer towards left. Suppose x equal to minus 2.9. So, greatest integer of minus 2.9 equal to minus 3. It always take nearest integer towards left on a number line. So, I'll take another example. Suppose I write f of x 1.5, greatest integer 1.5 is 1, nearest integer towards left. It is also called as step function. Step function. It is also called as step function. So, it is discontinuous at all integral values. Discontinuous at all integral values. So, discontinuous at all integral values. So, it is not a continuous function. So, you can write, so function is discontinuous where in the bracket x belongs to integers z plus always z minus in both. So, at 1 it is discontinuous, at 2 it is discontinuous, at 3 it is discontinuous. Now, of course, further classes will study. If I start from left to right towards 1, you are on this platform. When you are starting from 2 and going towards 1 from the right, you are here. Are they equal? No. So, function is discontinuous at x equal to 1. So, this is the step function. So, step function is discontinuous at all integral values as well as positive integers, negative integers. Of course, 0 is included. At 0 also it is discontinuous. Let us y equal to tan x. We will discuss y equal to tan x now. So, this line is pi by 2. This line is pi. So, this is 3 pi by 2. And this is 2 pi. And this is 0 minus pi by 2. Again, this is minus pi. You can put a pause and also can see. So, we have a time constraint. So, that's why a little you can see the fast, but you'll understand. I'll repeat, keep on repeating it. So, you'll draw a graph like this. So, this is the first quadrant. Again, starts from down and goes like this. This is second quadrant. And this is third quadrant. Okay. So, first quadrant tan x is positive. Second quadrant tan x is negative. Third quadrant tan x is positive. Fourth quadrant tan x is negative. What do you observe? Just keep on repeating. So, where it is discontinuous? At pi by 2, at 3 pi by 2. So, tan x is discontinuous at all x belongs to 2n minus 1 pi by 2. This is points of discontinuity. Points of discontinuity. So, tan x is discontinuous at all multiples of pi by 2, 2n minus 1 into pi by 2, not multiples of pi by 2. This is more specific. So, domain you know. So, x belongs to real numbers. X belongs to real numbers. Okay. Be precise. We remove all numbers 2n minus 1 pi by 2 because as x tending to pi by 2, tan pi by 2 is tending to infinite. Range is from f of x lies between minus infinity to plus infinity. What else you observe? It always repeats like this. What this with? Pi. So tan of x plus pi equal to tan x. So it is periodic with period pi. Periodic and with period pi. So after every pi it repeats. So very important, draw the graph of step x and as well as tan x. So tan x is discontinuous at all 2n minus 1 into pi by 2. What's the domain? X belongs to real numbers minus 2n minus 1 pi by 2. F of x from minus infinity to plus infinity. Tan x is positive in first quadrant, negative in second quadrant, positive in third quadrant, negative in fourth quadrant. And tan x is periodic with period pi. All these informations are useful in the coming chapters. So very, very important. Please write down. So domain and range. Next. So now we come to the basic definition. A real function f of x is said to be continuous at a point A of its domain if limit extending to a f of x exists and is equal to f of a. I'll elaborately explain you. I'll take this graph like this and this some point A. You are approaching A from left. You are approaching A from right. If both approaching value is same as f of A, obviously it is continuous. Okay, I'll take a practical example. Mr. A is coming from this direction. Mr. B is coming from this direction. They want to meet at a point where flag post is there. So A doesn't know B, B doesn't know A. They both have decided that they will meet at the flag post. As he is approaching A, approaching capital A, Mr. A, to the certain point of flag post, and Mr. B is approaching. So A is approaching from left, B is approaching from right, and they see the flag post also. So clearly it is continuous. Clearly it is continuous. Mathematically, what is the meaning of it? Limit extending to a minus f of x. The meaning is you are approaching A from left. From left. So this can again be written as limit extending to 0 f of a minus h. Take an example, a equal to 2 and you are approaching from left 1.99, 1.999, 1.999. So you are approaching to 2 from left. How mathematically we write? Limit extending to a, f of x can be replaced limit extending to 0 f of a minus h. This is also called as left hand limit. You are approaching limit from left side. Now right hand limit. So limit extending to a plus f of x is equal to limit extending to 0 f of a plus h. We solve this limit. Now limit extending to 0 is given. Normal limit chapter. We will solve it. And this is called right hand limit. Okay. So left hand limit is equal to right hand limit if both are equal, and it must be equal to value of f of a. So left hand limit is equal to right hand limit is equal to value of the function, then we say function is continuous. Another important definition. Whenever we write limit extending to a, f of x, this have two values. This is only possible when limit extending to a minus f of x is equal to limit extending to a plus f of x. If both are equal, then only we say limit extending to a f of x exists. When it will exist? When left hand limit, right hand limit both exist. Please, I am repeating once again. So when this is possible, when left hand limit is equal to right hand limit equal to, if these both are equal, then only we say limit exists, limit extending to f of x. Otherwise, other way we can say limit extending to f of x is only valid when you can write a specific value equal to f of a, when left hand limit is equal to right hand limit. Both exist and both must be equal. So you are approaching from left, approaching from right. Now, approaching from right, I write in this space 2.01, 2.0001, 2.00001. So you are approaching to from right. I hope you understood the basic definition. This is very, very important definition. All three must be equal. So limit extending to a f of x equal to limit extending to a minus equal to a plus equal to f of a. Then we say function is continuous. Here clearly mentioned. So this is right hand limit and this is left hand limit. This is called value of function. So left hand limit equal to right hand limit equal to value of the function. Then we say function is continuous. A real function f of x is said to be continuous at a point A of its domain. It must be in domain. If limit extending to a f of x exists and equal to f of a. So left hand limit is equal to right hand limit. This is right hand limit and this is left hand limit value. Here this is left hand limit, this is right hand limit. Both exist, then only limit extending to a f of x exists. Of course, we will discuss so many examples. Now I'll repeat once again neatly. Limit extending to a minus f of x is equal to limit extending to a plus f of x is equal to f of a. This is left hand limit is equal to right hand limit is equal to value of function. Then we say f of x is continuous at x equal to a. I'll take an excellent example of discontinuity, then you'll understand. F of x equal to greatest integer of x. Let us discuss at x equal to 2. So limit x tending to 2 minus greatest integer of x can be written as limit h tending to 0. This can be written as 2 minus h. 2 minus h means little less than 2. The value is equal to 1. So limit x tending to 2 plus greatest integer of x equal to limit h tending to 0. You will write 2 plus h. What you get? 2. Are they equal? No. So function is discontinuous at x equal to 2. So left hand limit is not equal to right hand limit. Therefore, f of x is discontinuous at x equal to 2. I hope you all have understood. I'll give 30 seconds. Please write down. Limit extending to a minus f of x equal to limit extending to a plus f of x equal to f of a. Left hand limit equal to right hand limit equal to value of the function. F of x is said to be continuous at x equal to a. Fx equal to greatest integer of x equal to 2 at x equal to 2. So limit extending to 2 minus greatest integer of x can be written as limit extending to 0. Replace x by 2 minus h because you are approaching from left is equal to 1. Similarly, limit extending to 2 plus means you are approaching x from right hand side of 2. You are approaching x from left hand side of 2. So both values are different. So left hand limit is not equal to right hand limit. Therefore, f of x is discontinuous at x equal to 2. Already I mentioned greatest integer of x is discontinuous at all integral values. So what is left hand and right hand continuity? Already I told you. Limit extending to a minus f of x equal to f of a, then f is said to be left continuous at x equal to a. Limit extending to a plus f of x equal to f of a, then we say fx is right continuous at x equal to a. I give an example to explain you more further. This is the graph. This is the graph of f of x equal to root x. This is x-axis and this is y-axis. What do you observe at 0? There is no function defined. What is the domain? X is greater than equal to 0. Domain is x is greater than equal to 0. Therefore, we write limit extending to a plus f of x is equal to f of a. This is right continuous. There is no function at all given. So this can be written as limit h tending to 0 f of 0 plus h, which is equal to f of 0. So it is right continuous. Similarly, if I draw a graph like this is 0, 0. This is x-axis, this is y-axis, function is not at all there. So this is under root of minus x. This is equal to f of x. So whenever you put x value, negative value, so what is the domain? Domain is x is greater than 0. Okay, so you understand like this. If I take negative values, x is less than 0. X is less than 0, then only negative becomes positive. X is less than equal to 0. So here there is no function defined on right. So we say it is a left continuous. Okay, so you can also write limit extending to 0 minus f of x is equal to f of 0. So we can write this as limit h tending to 0 f of 0 minus h is equal to f of 0. This is left continuity, right continuity. This is an excellent example, f of x equal to root x, to explain left continuity and right continuity. Here in left hand side there is no function defined. Here right hand side there is no function defined. It's a very important chapter. If you understand continuity differentiability, then it's very easy to understand the further calculus chapters. So you must more concentrate, understand, post your doubts. Definitely we'll clarify it. So f of x is discontinuous x equal to a in each of the following cases. Case 1, f of a is not defined and limit extending to f of x does not define. Now I'll take one by one. First type of discontinuity. Okay, so like this if we talk. Limit extending to a, suppose this is the point a, plus f of x is not equal to limit extending to a minus f of x. So left hand limit is not equal to right hand limit. Left hand limit is not equal to right hand limit. And it is not equal to value of the function. Suppose I write f of a. So left hand limit is not equal to right hand limit, or left hand limit is not equal to value of the function, or right hand limit is not equal to value of the function. So any one of this one, then we say function is discontinuous. This is discontinuity first kind. I'll repeat once again neatly. I'll write down. Limit extending to a plus f of x is not equal to limit extending to a minus f of x. Case 1. Limit extending to a plus f of x is not equal to f of a, and limit extending to a minus f of x is not equal to f of a. In all the three cases, we say function is discontinuous. Discontinuous. Function is discontinuous. So I hope you all understood. So left hand limit is not equal to right hand limit, or right hand limit is not equal to value of the function, or left hand limit is not equal to value of the function, then we say function is discontinuous. Next one. Now left hand limit is not equal to right hand limit. Okay, limit extending to a. Now this is actually two parts. Whenever they say this, they have two parts. Limit extending to a minus f of x. Other part is limit extending to a plus f of x. If both are equal, then we write like this. Another case, limit extending to a plus f of x does not exist. Does not exist. Limit extending to a minus f of x does not exist. Does not exist. Or f of a does not exist. Either of the cases, we say function is discontinuous. Either of the cases, we say function is discontinuous. So here right hand limit does not exist. Here left hand limit does not exist. Here value of the function does not exist. In any of the case, we say function is discontinuous. Suppose I take an example to explain you more appropriate. F of x equal to 1 by x. If we draw the graph of 1 by x, this is the 1 by x graph. What we see, left hand limit is not equal to right hand limit. As you are approaching 0 to from left, you will reach to minus infinity. If you are going right hand side, you reach to plus infinity. At 0, the function is not at all defined. You can't take 0. So left hand limit is not equal to right hand limit, even though at 0 does not exist. Clearly, this function is discontinuous at x equal to 0. Discontinuous at x equal to 0. I hope you have understood by this graph. Fx equal to 1 by x. Show that fx equal to x cube is continuous at x equal to 2. Mathematically, how we do? Limit x tending to 2 minus x cube. Step 1 equal to limit h tending to 0, 2 minus h whole cube. This will give you 8. This is left hand limit. So limit x tending to 2 plus x cube is equal to limit h tending to 0, 2 plus h whole cube will give you again 8. This is right hand limit. Now f of 2 is equal to 8. So what we observe? Limit x tending to 2 minus f of x is equal to limit x tending to 2 plus f of x is equal to f of 2. So function is continuous at x equal to 2. To explain, you don't have to draw the graph in PU, but I have to explain. I'm just drawing the graph. So graph look like this. This is x-axis, this is y-axis. So this is the point 2. So left hand limit is equal to, right hand limit is equal to value of the function. So function is continuous at x equal to 2. So you have to write in PU examination the same method. Even in competitive also, in rough work, you have to do like this to find the continuity of a function at a point. Concave down and concave up. Next, show that f of x 3x minus 2x is less than or equal to 0 and x plus 1x is greater than 0 is discontinuous. Same process. Limit x tending to 0 plus. 0 plus means greater than 0. You have to consider x plus 1. Next step, limit h tending to 0. You type 0 plus h plus 1. So it will give you how much? 1. This is nothing but right hand limit. Limit x tending to 0 minus less than 0. It is given 3x minus 2. So limit h tending to 0, 3. Wherever x is there, we write 0 minus h minus 2. You get minus 2. This is left hand limit. So right hand limit is not equal to left hand limit. You ask which is the value of the function. You have to take this. This is the function because equal to sign is given. So f of 0 we write as 3 into 0 minus 2 is equal to minus 2. So what we observe here is left hand limit is equal to right value of the function, but it is not equal to the left hand limit. Therefore, function is discontinuous. Therefore, f of x is discontinuous at x equal to 0. Function is discontinuous at x equal to 0. So left hand limit is not equal to right hand limit. But what we find, left hand limit is equal to value of the function, even though function is discontinuous. Same process. So show that fx is continuous at x equal to minus 3 but discontinuous at x equal to 3. So same way, limit x tending to minus 3 minus. So you are approaching minus 3 from left. So whenever mod x is defined, mod x have two parts. Equal to x whenever x is greater than equal to 0, minus x whenever x is less than 0. We are talking about less than, so this will be minus x plus 3. So we write limit h tending to 0 minus times of minus 3 minus h plus 3. So you get how much? 6. So minus minus plus 3 becomes 0. So minus 3 minus h. You are approaching from left. So minus 3 minus h. You are approaching from left. Means little away from negative direction of minus 3. So limit x tending to minus 3 plus. Minus 3 plus means little more than. This is minus 2x. Please very little carefully. Listen. Limit x tending to 0. Minus 2. What we write? Minus 3 plus h. This is also 6. Now, f of minus 3. F of minus 3. You take equal to sign is here. So we write mod of minus 3 plus 3, which is also 6. You will find left hand limit is equal to right hand limit equal to value of the function. Therefore, function is continuous. You got a clear picture. So many examples we have solved. Now we'll come for x equal to 3. So limit x tending to 3 plus. 3 plus means more than 3. Third function. 6x plus 2. Next step. Limit h tending to 0. 6 into 3 plus h plus 2. You get how much? 20. 6 3s are 18. Plus 2, 20. Limit x tending to 3 minus. 3 minus means minus 2x. So limit h tending to 0 minus 2, 3 minus h. You are getting how much? Minus 6. So left hand limit is not equal to right hand limit. So therefore, function is discontinuous at x equal to 3, but continuous at x equal to minus 3. Continuous at minus 3. I think you got an idea. Next one. So whenever left hand limit is there, we replace a minus h. Whenever right hand limit is there, we replace by a plus h. Same way, for all points of discontinuity f, where f is defined. Now, we have defined already mod x. Mod x equal to x whenever x is greater than equal to 0, and this equal to minus x whenever x is less than 0. So what he wants to say is f of x is x by x whenever x is greater than 0 will give you 1. F of x equal to minus x by x whenever x is less than 0, which is equal to minus 1. So clearly function is discontinuous at 0. At x equal to 0 it is 0. I draw the graph also. It is also called as Signum function. This is minus 1. I'll put a circle because it is at 0 it is 0 dot again 1. This is 1 and this is minus 1. So function is discontinuous at x equal to 0. By graphically also we have shown. So left hand limit is equal to minus 1. Right hand limit is equal to plus 1. F of 0, which is we say value of the function is 0. So function is discontinuous at x equal to 0. Function is discontinuous at x equal to 0. So it is also called as Signum x. You have studied in first year Signum x, SGN x. So function is discontinuous at x equal to 0. Now discuss the continuity of the function where f is defined. Fx equal to 2x when x is less than 0, 0 between 0 to 1. So let us check at 0. So limit x tending to 0 minus, you have to write 2x. This is can be written as limit h tending to 0, 2 into 0 minus h will give you how much? 0. This is left hand limit. So limit x tending to 0 plus already 0 is given. Next one, value the function f of 0 is equal to 0. So left hand, this is left hand limit, this is right hand limit, and this is value of function. So function is continuous at x equal to 0. All three are equal. Now let us check at 1. At x equal to 1. So limit x tending to 1 minus is 0. Limit x tending to 1 plus, it is 4x. This can be written as limit h tending to 0, 4 into 1 plus h, which is equal to 4. So clearly left hand limit is not equal to right hand limit. So left hand limit is not equal to right hand limit. So function is discontinuous at 0 and 1. So f of x is discontinuous at x equal to 0 and 1. There are 2 points of discontinuity. Normally in competitive they ask number of discontinuities. So this function is discontinuous at 0 as well as 1. I hope you all have understood. Same way, so example 6, same process. Limit x tending to 0 minus sin x by x. Now here less than 0 means sin x by x you are taking. So limit s tending to 0 sin of 0 minus h by 0 minus h. You know this can again be written as limit h tending to 0 minus sin h by minus h will give you 1. Already we studied in limits. So left hand limit is equal to 1. Right hand limit. So limit x tending to 0 plus, you get x plus 1. So limit h tending to 0, you write 0 plus h plus 1, again you get 1. So what we find, so left hand limit is equal to right hand limit. And what is the value of the function? You have to take f of 0 equal to 0 plus 1, which is equal to 1. So function is continuous. There is no point of discontinuity. So you replace by x by 0 minus h and 0 minus h. So you get sin minus h is minus sin h by minus h, which will give you 1. Limit h tending to 0 sin h by h is 1. So left hand limit is equal to right hand limit. This is left hand limit. This is right hand limit. This is value of function. This is value of function. All three are equal. So function is continuous at x equal to 0. There is no points of discontinuity. Next one, determine if the function given below is continuous x square sin 1 by x whenever x is not equal to 0 and 0. So same way, whenever x is not equal to 0 is given to you, straight away you can write limit x tending to 0 x square sine 1 by x. Here very important point we learn. Sine 1 by x always lies between -1 to +1. A finite quantity, a finite value, finite value. So, a finite value is multiplied by 0 is always 0. So, this is value is already 0 clearly. Don't write sine 1 by x by 1 by x. Wrong. Sine 1 by x is always a finite quantity. Finite quantity into x square means tending to 0 is always 0. The value of the function is given to you. This is equal to f of 0. So function is continuous. Why? I repeat once again, sine 1 by x is always a finite quantity. Finite quantity into 0. Finite quantity into 0 is equal to 0. So therefore, function is continuous everywhere. X square sine 1 by x is continuous everywhere. I hope a simple example. So finite quantity into 0 is always 0. Now we move on to next example. So remaining problems we'll deal next class. But before, one more very important thing is there. Limit extending to a minus f of x is equal to limit extending to a plus f of x is not equal to f of a, then we say removable discontinuity. Suppose a road is made and there is a small hole, pothole. Normally it is there in Bangalore, you have seen every road. So when you fill the pothole, so what happens? It becomes continuous. So limit extending to a minus f of x equal to limit extending to a plus f of x is not equal to f of a, then we say it is removable discontinuity. Remaining all discontinuities what we discussed is non-removable discontinuity or discontinuity of second kind. So why it is called removable discontinuity? You can give a f of a value which is equal to both. We will discuss the examples, you will understand. So it is this limit extending to a minus f of x equal to limit extending to a plus f of x is not equal to f of a, then we say it is removable discontinuity. Please remember this. So left hand limit is not, left hand limit is equal to right hand limit is not equal to the value of the function. Then we say it is removable discontinuity. I try it once again. LHL equal to RHL, but it is not equal to value of function. Then we say it is removable discontinuity. So we have learnt the basic definition of continuity. Basic definition of continuous functions and discontinuous functions. We have studied. And periodicity also we studied. Please remember f of x plus t equal to f of x. Then f of x is periodic with period t. So periodic function also we studied. So definition of continuity we studied, and definition of periodicity we studied, and we studied discontinuity of the function also. So we have solved some few examples of discontinuity. Also, please draw the graph of f of x equal to greatest integer of x. Draw the graph of f of x is equal to sine x, and f of x is equal to tan x. These are the graphs we have studied. So in further classes, we'll study the remaining graphs. So, review of today's lecture, read the NCERT textbook and complete homework that will be posted